Hey there, space enthusiasts. Welcome back to SpaceX Central, where we bring you the most in-depth SpaceX analysis on YouTube. I'm your host, and today we've got some absolutely incredible content lined up for you. We're about to dive deep into some game-changing revelations. Brand new footage from Starship Flight 8 has just been released, and what we're seeing is going to blow your mind. We're talking about exclusive angles of the catastrophic engine failure that took down Ship 34, captured in detail that was never shown on the public livestream. But hold on, because that's just the start. We're also going to explore something even more thrilling, SpaceX's groundbreaking Raptor 4 engine that's set to completely revolutionize space propulsion as we know it. If you're joining us for the first time, make sure to hit that subscribe button and ring the notification bell. Trust me, after today's comprehensive breakdown, you'll see why the coming years are going to be the most game-changing period in spaceflight history. All right, let's dive right in. As we look ahead to the much-anticipated Flight 10, we need to understand exactly what went so wrong during Flight 8. This wasn't just another spectacular failure. It was an engineering masterclass that's directly shaping Starship's future development. Recently released internal footage gives us a completely new perspective on Ship 34's final moments. These exclusive behind-the-scenes images show details that are both absolutely fascinating and genuinely terrifying. Picture this scene: a Raptor engine literally torn to pieces, completely exploded and separated from the spacecraft. In this never-before-seen photograph, you can see the engine's nozzle split completely down the middle. The upper section is totally shredded and peeled open like a banana. The protective outer shell is gone entirely, exposing the complex inner mechanisms that were never designed to be exposed to such destructive forces. Debris fragments fill the entire frame, each piece telling the story of incredible violence. This isn't just an engine shutdown. We're looking at complete structural destruction at the molecular level. The other newly released images are equally dramatic. In one frame, two Raptor vacuum engines are completely surrounded by flames, looking like something straight out of a science fiction disaster film. In another shot, smoke and vapor are blasting outward from the sea-level engines like a massive industrial explosion. By comparing these images with the live stream footage, we can now build a precise timeline of the disaster. At approximately 7 minutes and 45 seconds into the flight, fires and thick smoke plumes first become visible within just 20 seconds. And I want you to really think about that. Just 20 seconds. The situation falls apart so rapidly it's almost impossible to believe. By 8 minutes and 5 seconds, one vacuum engine and 3 sea-level Raptors have completely failed. Explosions are erupting across the screen in a cascade of destruction. The loss of multiple engines throws off the thrust balance so severely that losing control becomes unavoidable. Here's what makes this evidence particularly fascinating. The image showing the engine falling away from the spacecraft can't be found anywhere in the public footage. This strongly suggests it was captured using SpaceX's internal diagnostic cameras, giving us an unprecedented look into just how severe those critical moments really were. SpaceX's official analysis blamed the vehicle loss on hardware failure in one of the central sea-level Raptor engines. The failure allowed fuel and oxidizer to mix unintentionally, which triggered the massive explosion we all witnessed. The photographic evidence strongly supports this explanation. Picture this scenario: a deep crack probably formed in a critical structural area, maybe between fuel lines or in a high-stress joint. This crack grew over time under enormous operational stresses, forces and temperatures that would destroy conventional materials in seconds. When the structural limit was reached, the crack expanded catastrophically, causing sudden and complete rupture. The clean split we can see in the engine nozzle suggests the structural failure began well before the final burnout, as the failing engine fell apart. Debris and superheated gases likely damaged neighboring components, starting a devastating chain reaction. In such high-stress, high-temperature environments, even a single compromised engine can cause absolute chaos in just moments. This is the reality of pushing the boundaries of rocket science. Sometimes the frontier pushes back hard. Despite Flight 8's severity, SpaceX showed exactly why they lead the aerospace industry by responding with incredible speed and precision. For Flight 9, Raptor engines were upgraded with key improvements that directly address Flight 8's failure modes. These improvements included significantly stronger structural joints with increased preload, essentially making the engines more resistant to the crack propagation that destroyed Ship 34. They put in a new nitrogen purge system specifically designed to prevent the unintentional propellant mixing that triggered the explosion. SpaceX also installed more efficient fuel drainage systems to reduce residual propellant risk during engine operation. These improvements built on earlier adjustments after Flight 7 when harmonic vibrations caused premature engine shutdowns. While Flight 9's engine performance was dramatically more stable, that mission faced a completely different challenge: a propellant tank leak causing pressure drop that starved the engines of fuel, eventually causing Ship 35 to lose control in a different failure mode. This perfectly illustrates the incredible complexity of SpaceX's mission. Each flight reveals new challenges, and each challenge drives innovation that makes the entire system more robust. This brings us to one of the most exciting developments in modern aerospace engineering: the evolution of SpaceX's Raptor engine family. What we're witnessing isn't just gradual improvement, it's a complete revolution in rocket propulsion philosophy. For over a year, the space community has been eagerly waiting for Raptor 3, but SpaceX has already started teasing something even more revolutionary: Raptor 4. This represents the next quantum leap in propulsion technology. The sleek black Raptor 3 that was unveiled last year serves as the mechanical heart of Starship version 3. This larger, more capable Starship variant will stand nearly 150 meters tall, taller than a 40-story building, and is expected to debut within the next few months. But here's where it gets really exciting. Hints about the next generation Raptor 4 first came up during a fascinating interview between Elon Musk and everyday astronaut. Musk mentioned an engine version capable of producing 330 tons of thrust, a number that should absolutely blow your mind. For context, Raptor 3 delivers around 280 tons of thrust. A 330-ton version clearly represents something far more advanced, indicating the introduction of a completely new engine generation that will redefine what's possible in space. Let's talk about what these numbers actually mean, because they are absolutely staggering. With the planned output of 330 tons, Raptor 4 will be approximately 17% more powerful than Raptor 3's impressive 280 tons. Compared to the current Raptor 2 engines, we're looking at a mind-blowing 43% increase in thrust. If SpaceX maintains the current Starship architecture, super heavy boosters equipped with Raptor 4 engines could generate up to 890 tons of liftoff thrust. That's more than triple the thrust of the legendary Saturn V rocket that took humans to the moon. Future configurations suggest Super Heavy could carry 35 engines, while the ship itself could hold 9 sea-level engines, plus 3 vacuum variants. This setup could push total liftoff thrust past 11,500 tons, while the ship alone would exceed 3,000 tons of thrust, nearly matching Saturn V's total lift capability. But raw power is only part of the story. Perhaps even more impressive is SpaceX's revolutionary approach to engine design philosophy. Radical simplification that makes these incredible performance gains possible. With Raptor 3, SpaceX made remarkable progress in reducing complexity by integrating or eliminating many small, failure-prone components. Raptor 4 is expected to continue this trend, and the implications are profound. Simplified design doesn't just improve reliability, it makes manufacturing faster, more cost-effective, and enables the rapid production SpaceX needs for their ambitious mission schedules. By eliminating flanges and bolts, which are notorious sources of leaks and mechanical failures, SpaceX is moving towards seamless construction that relies heavily on advanced welding techniques. This creates stronger, leak-resistant joints while dramatically increasing overall reliability. The numbers tell an incredible story of progress. The original Raptor 1 weighed about 2 tons. That was reduced to 1. 6 tons in Raptor 2. By Raptor 3 production, The weight dropped to just 1.525 tons. When you apply this mass reduction across dozens of engines per rocket, you get significantly lighter launch vehicles, which translates directly into dramatically improved performance and efficiency. So when will we actually see Raptor 4 in action based on SpaceX's broader mission schedule and development goals? Raptor 4's debut is likely still a few years away, probably not until 2028 or beyond. This timeline aligns perfectly with SpaceX's incredibly ambitious roadmap. By 2028, SpaceX expects to complete initial human landing missions under NASA's Artemis program. Following those landmark missions, the company will need significantly more capable Starship versions to transport larger crews and heavier cargo as they begin building sustainable lunar bases. That time frame also aligns perfectly with Musk's Mars exploration vision. This will be the period when SpaceX begins installing the first permanent systems on the Martian surface, following successful demonstration missions that prove Starship's ability to reach and land on the red planet reliably. While we wait for Raptor 4, we can look forward to witnessing Raptor 3's remarkable performance. This new engine version is scheduled to launch later this year, likely around the time SpaceX attempts one of its most ambitious tasks yet, catching both Starship stages using the Mechazilla arms for the first time in history. Following that milestone, the focus will shift toward building and testing in-orbit refueling systems, which are directly tied to the Starship version 3 design. After the refueling systems are operational, SpaceX will deploy specialized lunar Starship variants for unmanned demonstration missions preparing for future crewed lunar landings. The most historic mission will be Starship's return of humans to the Moon, marking over 50 years since humanity last walked on the lunar surface. From Flight 8's dramatic engine explosion lessons to Raptor 4's revolutionary promise, SpaceX continues pushing the boundaries of aerospace engineering. The newly revealed Flight 8 footage reminds us that rocket science progress isn't always smooth, but every failure teaches us something crucial about the physics we're trying to master. Those exploded engine fragments aren't just debris, they're data points that are informing the design of engines like Raptor 4. Are you excited about the upcoming Raptor engine evolution? Drop a 4 in the comments if you can't wait to see Raptor 4 in action. And let me know what aspect of this engine development excites you the most. Don't forget to give this video a thumbs up if you found this analysis helpful, and subscribe to SpaceX Central for the most comprehensive coverage of humanity's journey to the stars. Hit that notification bell so you never miss our breaking SpaceX coverage. This has been your host reminding you to keep looking up toward the infinite possibilities waiting for us among the stars.